All right, get ready, because over the next few minutes, we're going to take everything you think you know about reality, time, space, even solid stuff, and just boop, flip it on its head. And we're going to start by asking a question about something you see every day.
Okay, here's a question that sounds, well, almost a little silly. Why don't broken cups just put themselves back together? You drop a mug, it shatters into a million pieces. We all know it's not going to magically reassemble itself on the floor. But the real mystery, the deep question, isn't that it doesn't happen. It's why not? I mean, really, what's stopping it?
Because when you dig into that simple question, you find this huge, glaring contradiction. See, in our world, time is a one-way street, right? Yesterday is gone, tomorrow isn't here yet. But the fundamental laws of physics, the ones that run everything, gravity, electromagnetism, all that stuff, they don't care about the direction of time. They work perfectly forwards and backwards. If you watched a movie of a planet orbiting the sun, you couldn't tell me if I was playing it forward or in reverse. It would look totally normal either way. So, what gives? Why is our world so stuck on moving in only one direction?
The answer, it turns out, has to do with this thing called entropy. Now, you've probably heard it described as just disorder, but that's not the whole story. It's actually a bit more precise than that. Think of entropy as a measure of how many ways you can arrange something. An unbroken cup, that's a highly ordered state. There's really only one way for it to be an unbroken cup. But a shattered cup? Oh man, there are countless, billions of ways those pieces can be scattered on the floor. Way more possibilities.
Let's make it even clearer. Imagine a box with a divider down the middle. On one side you have one type of gas, and on the other side another. That's super specific, right? A low entropy state. Now, what happens when you pull that divider out? Whoosh, they mix. Every single time. And it's not because of some weird mixing force pushing them, it's just statistics. There are just astronomically more ways for all those little molecules to be jumbled up together than for them to be perfectly separated. The universe is lazy. It just falls into whatever state has the most options.
And this is the big reveal. The reason a cup doesn't reassemble itself is the exact same reason the gases don't magically unmix. It's not forbidden by the laws of physics. It could happen. It's just that the odds of all those broken pieces flying back into that one perfect arrangement are so ridiculously, astronomically, mind-bogglingly small that you'd have to wait longer than the age of the universe to see it. So the arrow of time, it's not some fundamental law, it's just probability. The universe is just playing the odds, and the odds are overwhelming.
But wait a second, that just raises an even bigger question, doesn't it? If everything is always moving from order to disorder, then that means the universe must have started in a state of incredible, unbelievable order. And that's exactly what we think happened. The Big Bang wasn't a chaotic explosion. It was an intensely ordered, low-entropy beginning. And everything that's happened since, the formation of stars, planets, even us, is just part of that initial order slowly, inevitably, beautifully unwinding.
Okay, so we've kind of redefined time. It's not a river, it's more like the universe cashing in on probability, all stemming from that first perfect moment. But what about the stage itself? What about space? Is it just an empty box? A big, boring container for all the stuff? Oh, you know the answer's going to be way, way weirder than that.
Yeah, modern physics hits us with this total mind-bender. It suggests that space is finite. You could, in theory, measure its total volume, but at the same time it's unbounded, meaning there's no edge, no wall at the end of the universe. How is that even possible? How can something have a size but no end?
Well, let's try an analogy. Imagine you're a little two-dimensional bug living on the surface of a giant beach ball. To you, your whole universe is just that surface. You can go forwards, backwards, left, right, but up and down don't exist for you. Now, what happens if you start walking in what feels like a perfectly straight line? You just keep walking and walking. You never hit a wall, you never find an edge to fall off of. And then the craziest thing happens. You end up right back where you started. Your 2D universe has a finite surface area, but no boundary. Well, the thinking is that our 3D universe might be doing the exact same thing, just curved through a fourth dimension that we can't perceive. So what's doing all this bending and curving? Mass. This was Einstein's big breakthrough. Gravity isn't some mysterious, spooky force pulling you down. No, gravity is the shape of space-time. Big things, like the sun, literally put a dent in the fabric of space-time, and planets, like Earth, aren't being pulled. They're just rolling along the straightest possible path in that curved space. It's like a bowling ball on a trampoline making a marble circle around.
All right, so space is this big, bendy fabric on the cosmic scale. Got it. But let's zoom in.
like way, way in. What about the so-called empty space right in front of your face? The space between the atoms in your body and the atoms in the air? Surely that's empty, right? Just nothing?
Nope, not even a little bit. In fact, get this. You have never, ever actually touched anything in your entire life. Right now, you're not actually touching the chair you're sitting in. You're hovering an infinitesimally small distance above it. What you feel as solid is just the powerful electromagnetic repulsion between the electrons in your atoms and the electrons in the chair's atoms. They're pushing against each other like two powerful magnets. There's always a gap.
Okay, but let's push it. Let's say we could somehow create a perfect vacuum. We suck out all the atoms, block all the light, get rid of everything. Then it would be empty, right? Well, quantum mechanics has a truly shocking answer for us. No. Even then, it wouldn't be empty. Because it turns out that absolute, total nothingness is literally forbidden by the laws of physics. Nature just refuses to be nothing.
Instead of being empty, the vacuum is, well, it's buzzing. It's seething with activity. All the time, everywhere. Pairs of what we call virtual particles just pop into existence out of nowhere. They exist for a fraction of a second, an impossibly short amount of time, and then, poof, they crash into each other and disappear back into the nothing they came from.
How on earth is that possible? Well, it's a little loophole in the laws of physics called the uncertainty principle. It basically says you can borrow a tiny bit of energy from the vacuum to create a pair of particles, as long as you pay it back really, really fast by having them annihilate each other. It's like a cosmic energy loan. The bigger the loan, the faster you have to pay it back. So what we call empty space is really this insane nonstop dance of particles borrowing and repaying energy.
And this leads to maybe the biggest mental shift of all. The particles that make you up, the electrons, the quarks, the whole gang, they're not tiny little billiard balls. They're not stuff at all. The best way to think about them is as tiny vibrations, little ripples in giant invisible fields that fill the entire universe. There's an electron field, a quark field, and a particle is just when that field gets excited in one particular spot.
And that just changes everything, doesn't it? The universe isn't a bunch of things sitting in an empty box. It's this buzzing, shimmering, dynamic web of interacting fields. So matter isn't really a thing at all. It's an event. It's something that's happening.
Which means you aren't a collection of stuff either. You are a pattern. A really, really complicated and beautiful pattern that somehow managed to keep itself going. You're a ripple in these cosmic fields that got so complex that it started to wonder what it was made of.
And that brings us all the way back to the beginning, back to entropy. You know, we like to think that life is this noble struggle against the universe's tendency toward disorder, but actually, the opposite is true. Life is one of the most efficient things the universe has ever invented for increasing entropy. You are a little engine of disorder. You take in ordered energy, like food, and you pump out disordered energy, like heat, all just to keep your own temporary, beautiful pattern going for a little while longer.
So let's just take a breath and recap this new reality we've just uncovered. Time moving forward? That's just probability playing out. Space? It's a dynamic, curvy fabric. Gravity? That's just the shape of that fabric. Empty space? It's a buzzing hive of quantum activity. And solid matter? It's just a ripple, a pattern, an event happening in that space. And the biggest takeaway of all? You're not in the universe. You are the universe. You are a piece of the cosmos that has woken up and is trying to figure itself out. So, if you're not a static thing, if you're a dynamic, unfolding process, a temporary pattern riding this giant wave of cosmic entropy, then there's really only one question left, isn't there? What kind of process are you going to be?